Check it.
Okay, welcome back. Today we're going to be talking about nth roots, okay? So you guys know what a square root is, but there are other kinds of roots other than square roots, where there are cube roots and fourth roots and fifth roots and sixth roots and so on and so forth. They go on forever. So it isn't just about square roots. That's why the symbol here, we don't call it the square root symbol, we call it the radical symbol. The reason being is that it might denote a square root, or it also could denote a cube root, or a fourth root, or a fifth root. So we just call it an nth root for any number n. N can be any number, so that's called a radical symbol. It's not called a square root symbol. Anyway, before we get into nth roots and all different kinds of roots, let's just talk about square roots for a moment. I have two questions on the screen here. I have, what is the square root of 25? And then I have this thing here that normally people would look at as the square root of 25 equals. And my question is, what is the difference between these two questions? Why are they different, or are they different? And if this were a normal classroom, I would wait till everybody raised their hand and people would throw out their ideas about why, or whether or not they're the same. And a lot of people would answer the first one. They would say, what is the square root of 25? A lot of people would just say 5, and a lot of people would say this is 5, and say that they're the same question. And you usually get one person, okay, in every class, or one or two people in every class that would say, well, what about plus or minus 5? Because couldn't you square negative 5 and get positive 25? And I would go, yeah, that's, okay, cool, you're getting warmer. But they still wouldn't know what the difference is between these two questions. And they are different questions, okay? One is asking you, what is the square root of 25? And 90% of the students will tell you that's a 5 only. And then this one here, the ones that do go with the plus or minus, they would think that the plus or minus was for this one. And they would actually be backwards. They would be wrong, okay? So let's talk about this. What is the square root of 25? The square root of a number is the number you would square to get that number. So what would you square to get 25? Well, you could square 5, and you could also square negative 5. So yeah, you could say this one is plus or minus 5. However, this symbol here is not asking you for the square root of 25. It's asking you for what's called the principal root of 25. The principal root, okay, the principal root of a number is not the square root of a number, it's the positive square root of a number. Because we've already seen up here that there are actually two square roots of 25. This symbol, this radical symbol here, isn't asking you for the square root of 25, it's asking you for the square root of 25 that is positive, and the answer here is only 5. So there's a difference between this symbol and a true square root. A true square root has two values. A square root of a positive number has two values. A square root of a negative number doesn't exist. But this radical symbol is not asking you for the two, so it's never plus or minus 5, and a lot of teachers don't even know this. Okay, it's just the positive root. Okay, and this explains why I've been telling you guys all year that the square root of x squared is not x. Okay, once again, something a lot of teachers don't know. All right. The square root of x squared is not x. The square root of x squared is the absolute value of x. So when you have an equation x squared equals 25 and you go to solve it by square rooting both sides, a lot of people think that this, when you square root this, you get x, and when you square root the 25, you get plus or minus 5. Now the answer is right, but everything in between is wrong. Okay, what's actually happening here, and we've learned this along the course of the year, is that this is actually the absolute value of x. And this, as I've just shown you, is not plus or minus 5, it's only 5. And then when you take the absolute value of x here, right, what would you take the absolute value of to get 5? That's when you get your plus and your minus 5. But that middle step is usually not understood, and I'm making sure that you guys understand it because it does bite you in the butt later on in calculus. So let's just make sure we get this right. So the difference between a square root and this radical symbol is only asking you for the positive root. Okay, so now we go into nth roots. Okay, we talked about square roots. What are the other possible roots? Well, you have a third root, also known as a cube root, just like a second root. Now, a second root is a square root. Square root is what you would square to get that number. It's what you would take to the second power. there's a little number here that we don't write that's supposed to be a 2 on a square root, but we don't write it because we don't need to. If there's nothing, this is called, by the way, this is called the index number. Here it is here, the index number. So if there is no index number, we know that to be a square root, right? And it's assumed that there's a little 2 here, but it's invisible. Just like we don't write the power of 1 on most things. But if there is a number here, then we assume that whatever the number is, that's whatever the index number is, that's the root that we're talking about. So for a square root, there's no index number. The little 3 here, that's a cube root. All right? The question is, what would you cube to get 27? Okay, what positive number would you cube to get 27? And the answer is 3. 3 to the third power is 27, right? Well, I shouldn't put it right there. Okay, over on the side here. 3 to the third power is 3 times 3 times 3, which is 27. And if I know that, then I know the answer here is 3. What is the fourth root of 16? Well, what times itself 4 times will give you 16? It turns out that 2 times 2 times 2 times 2, aka 2 to the fourth power, is 16. So the fourth root of 16 is 2. What is the fifth root of 32? Well, if you're paying attention here, 2 times 2 times 2 times 2 is 16. Just add another, well, not add another, but multiply by 2 another time. So you get 5 of them, right? And wouldn't that be 16 times 2, which is 32? And that's 2 to the fifth power. So the fifth root of 32 is also 2. I'm using simple numbers here to get you acquainted with the idea. But that's what an nth root is. It's any index number, okay? Now, what do we know about square roots that's really important? You cannot square root a negative, right? Why is that? Because anytime you take a negative number and you square it, you don't get a negative. You get a positive. Negative 2 squared is 4. Thereby, the square root of 4 is 2, or it could be negative 2. Okay, oops. Well, that symbol is the principal root, so I'll put a plus or minus here. However, if you try to square root negative 4, you get no real value. There's nothing here that you would get an imaginary number, okay? You can't square root a negative number because squaring a negative number does not give you a negative 4. It gives you a positive 4. But what about cube roots? Okay, let's take a look here. So we already know the square root of negative 16 is impossible. Let's just write DNE for does not exist. Okay, not a real number. But what about the cube root of negative 27? We just learned a minute ago that if you take 3 to the third power, you get 27. Is there a number you can take to the third power to give you negative 27? So let's come over here. What if you took negative 3, multiplied it by negative 3, and multiplied it by negative 3? Because there's an odd number of negatives, the first 2 negatives will cancel out, but there'll still be one more negative that will survive, and you will get negative 27. So for an odd power, you can get a negative result. Thereby, for an odd root, you can take the odd root of a negative number. And the answer here is negative 3. So while you cannot square root a negative number, you can cube root a negative number, no problem. Okay? Now, what about the fourth root of 16? We know that 2 to the fourth power is 16 from a few minutes ago. But if you have 4 of them, negative 2 times negative 2 times negative 2 times negative 2, what's going to happen is every 2 negatives will cancel out. These 2 will cancel out. These 2 will cancel out. And you'll still get positive 16. You won't get a negative number. So this is impossible. Does not exist. Okay? Why? Because it's an even power. And an even power has an even number of negatives. And an even number of negatives, they all pair up and cancel each other out. There's no odd man out. There's no extra odd numbered power here to give us an extra negative. On the other hand, the fifth root of 32 has 5 negatives, right? It's just like this, except there's 5 of them. These 2 will pair up and cancel out. These 2 will pair up and cancel out. But you have the odd man out here, which means you will have a negative 32. So this is negative 2 right here. You can do it. So the moral of the story here is you can do roots of negatives as long as it's an odd root, not an even root. Even roots, like square roots, you can't do a square root of a negative number. You can't do the fourth root of a negative number. You can't do the sixth root of a negative number. You can't do the eighth root of a negative number. Any even root has to be a positive number inside. Otherwise, problem. But odd roots, go crazy. You can do odd. So you can do positive, negative, doesn't matter. So just understand that for odd roots, negatives are possible. So what if you're taking roots of numbers? What about taking roots of variables? So what's the square root of x to the fourth power? What would you square to get x to the fourth power? Well, if you think about it, wouldn't x squared times x squared give you add the powers x to the fourth? Yeah. So the answer here is x squared. However, this right here, what would you square to get x squared? Well, using that same argument from up here, you'd say it was x. But I've told you in the past, it's not x, it's the absolute value of x. So how do you know that? Or what's the difference here? Well, the difference is that this is an x to the power, we don't write it, but it's a power of 1. It's an odd power. So here's the thing. When you go from an even power, because 2 is an even number, to an odd power, because 1 is an odd number, when you go from an even power to an odd power, you need absolute value bars. Okay? And the reason why I explained this earlier in the year, but I'll just run through it again, is because you don't know what what sign x is. X could be a positive 3, it could be a negative 3, it could be a positive 5, it could be a negative 5. And if x is a negative number, when you square it, it's going to look positive. So x squared, no matter what, has to look positive because it's an even power. But then when you square root it and it goes to an odd power, now that masking is gone and you don't know if this is positive or negative. The best you can say is that its absolute value is a certain thing, right? You don't know if it's positive or negative, and thereby you must use absolute value bars, okay? But this doesn't just apply to, well, in the past it was only x squared, the square root of x squared is absolute value of x. But what about any time you go from an even power to an odd power? This is going to happen as well. So let's keep going. You probably are figuring out that all you're really doing here is dividing the power by the root. So 16 divided by 4. 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. So really, you're just dividing the power by the root. Power by root, 4 divided by 2, you get 2. Now, why are there no absolute value bars here? Because you went from even to even. Okay, where do you need bars? Even to odd. Remember that. Not odd to even, not even to even, not odd to odd. Only one way. Even to odd requires bars. So let's try this one here. We divide the power by the root. 16 divided by 4 is 4. We get x to the fourth. Now, look at it. X to the fourth. Did we go from even to odd? No, we didn't. We went from even to even, so box your answer. There's no bars necessary. However, for this one, this is going to be 12 divided by 4, which is 3, so we get x to the third. We went from an even power, where the negative would be disguised, to an odd power, where the negative wouldn't be disguised. And because we went from even to odd, we do need absolute value bars around this answer. Otherwise, it does not work. When you go from an even power to an odd power, after taking a root like this, you must use absolute value bars. Okay? Even to even? No. Odd to odd? No. Odd to even? No. Just even to odd. Now this one's got two things inside the square root. It's got a 25 and an x to the fourth. Okay? It's 25 times x to the fourth. And you can, we learned this back when we did imaginary numbers. You can factor a radical into one thing times another. So we can break this up into the square root of 25 times a separate square root for x to the fourth. Okay? And by doing that, we can now, basically, I'm going to refer to it as chopping up. We can chop this up into two square roots, and now this becomes a 5 because, once again, the principal root only, the positive root only is 5. And now what's this going to be? Well, we're going to divide this 4 by the invisible 2 here, right? There's a 2 here that we don't write, and we get x squared. We went from even to even, so there's no bars, and we box our answer. Here we have 3 things. We have 3 things inside the root, so we're going to chop this up into 3 roots. We have the square root of 36, the square root of a to the 6th, and the square root of b to the 12th. All right? The square root of 36, or radical 36, is 6. Okay, principal root only. This is going to be the 6th power divided by the 2nd power, right? And 6 divided by 2 is 3, so this is a to the 3rd. But wait, that was an even power that became odd, so you need absolute value bars on this. And now here you have b to the 12th, second root. So 12 divided by 2 is 6. So this becomes b to the 6th. Now, if you have absolute value bars, they have to be on the end of the expression. So we have to rewrite this. So we get 6, and then the b to the 6th, and then the absolute value bars go on the end here. And there's our answer. Okay? You don't leave the bars in the middle like that. You move it out to the end. Okay, let's try one more. Okay, same question on steroids here. Okay, chop it up. You have 4 roots to deal with here. So we got the square root of, my colors won't change fast enough here. You get the square root of 49. You get the square root of x to the 10th. You got the square root of y to the 12th and the square root of z to the 2nd. Remember, this is a second root, square root. So all of these have to be the same root. Okay, all of these. If this was a cube root, all of these would be a cube root. Okay, don't like just put a cube root on the first one and do square roots for the rest. That does not work. Okay, what's the second root of 49? The principal root here is going to be 7. And this one's going to be x to the 5th because 10 divided by 2 is 5. And hopefully you notice that 10 is even, 5 is odd, bars, you need bars, okay, for that one. This is going to be y to the 6th, no bars, because even to even. And in this one, you're going from 2 divided by 2 is 1, to 1. Okay, we don't write it, but there's an invisible 1 here. And when you go from 2 to 1, the square root of z squared is not z, it's absolute value of z. Okay, the same reason why the square root of x squared is absolute value of x, because you're going from 2 to 1 on the power. You're going from x squared to x to the first. 2 to 1 is even to odd, so we need to put the bars around it. Well, we're just doing it with z now. And you see, if you look at the way I wrote the answer here, this is really confusing because we have 4 bars and it looks like the y to the 6 is in bars, right? So it's confusing the way it's written. So what we do is, like I told you, take all the bars and put them on the end. And if you have more than one thing in bars, combine them into a single set of absolute value bars. So take the stuff that's not in bars. The 7 was not inside absolute value bars. Neither was the y to the 6th. Put those first. Now the stuff in the bars, the x and the z, put them in one big set of bars. That's it. Combine them into one set of bars. You should not have more than one set of absolute value bars. And that's it. Okay, and that's the proper way to write that. Okay, let's get a little more complicated now. You had to know that it was going to get harder. Okay, so now we have a 4th root, which is an even root. Now, an even root, you can't have a negative. You can't take the root of a negative. However, there is a negative out here. Now, you're going to see a lot of this in the homework where there's either a negative or a plus or minus outside of the radical. Anything outside is, don't even worry about it. I mean, yeah, you got to copy it. It can't just make it disappear. But it's not the same as being in here. If there was a negative in here, right away this would be impossible because you cannot take an even root of a negative number. Right? Just like you can't square root a negative number, you can't take the 4th root of a negative number. But this is not negative inside, there's a minus outside, and that's fine. Just ignore it pretty much. So what do? Well, you're going to chop this up. Chop, chop, chop. Right? And now what are you going to get? Well, that negative that's out there, you're just going to copy it because it's just going to be sitting out there like a spectator. Okay? Then you got the 4th root of 16. So make sure you put a 4 on this root. You got the 4th root of a to the 12th. Once again, 4th root, okay? You got a 4th root of b to the 8th, and you got a 4th root of c to the 20th. One of the mistakes that people tend to make, that students tend to make, is that they'll write the 4th root on the first one and then forget the 4th roots on these and do square roots on the rest. No. Okay? If this is a 4th root, when you chop it up, each one is a 4th root. Okay. Now, can you take the 4th root of 16? Yeah, we did it before. It's 2. It's positive 2. But there's also that negative hanging out outside. So just bring that negative down. It's just going to sit there. Like I said, it's like a spectator. It doesn't do anything. It just stays where it is. Now this is going to be a to the what? 12 divided by 4. A to the 3rd. And we went from an even to an odd power. So there are bars on this. This one, b to the 8th, 4th root. 8 divided by 4 is 2. This becomes b squared. And c to the 20 divided by 4 is c to the 5th. 20 is an even number, 5 is an odd number. We need bars again. And once again, we have that confusing looking situation again. So what we do is we take all the stuff that wasn't in bars, the -2 and the b squared, put them first, and then the a cubed and the c to the fifth, which are in bars, put them into one big single set of bars, like that. And there's your answer for that example. Now this next one here has parentheses in it. You're going to see a bunch of these on the homework. And here's a deal. When you go to chop this up, okay, the 64 is one part, yes. But do not chop up what's inside the parentheses. What's in the parentheses must remain intact. Do not try to chop that up like that. No, no, no. Okay? So what you have here is you have this. You got this plus or minus, which is a spectator just hanging out outside. Don't worry about that. You got the square root of 64, which we all know is 8, right? And then you have the square root of this thing in parentheses to the 6th power. Now, it doesn't really matter what's inside the parentheses. It doesn't. You just understand that there's something there's a set of parentheses and there's something in there. And you cannot break up that parenthesis, right? You cannot break up that set of parentheses, and there's no way to chop that up. So that has to stay intact. This x plus 3, whatever it is in here, you can't mess with it. And how do you deal with the parentheses? Do you distribute something? No, you don't. Here's what you do. We've done this earlier in the year with quadratic form. You're going to do what's essentially a u substitution here. So we're going to say let u equal this set of parentheses here, x plus 3. Why am I putting parentheses around it here as well? Only just so it'll match. The truth is, you know, it's fine if it's without parentheses, but you'll see what I'm talking about in a moment. So I'm going to put parentheses around it cosmetically, even though they're not doing anything. Now, what this means is that this 64 here becomes an 8. So let's just get that out of the way, okay? This one right here becomes not x plus 3 to the 6th, it becomes u to the 6th. And you know how to take the root of u to the 6th, okay? U will divide the 6 by 2 and get u to the 3rd, like that. So you still have the 8 here, you still have the plus or minus. But here's the thing, you can't box your answer. Well, there's two things we have to do. First of all, we just went from a 6th power, which is even, to a 3rd power, which is odd. So we need absolute value bars around that u, first of all. But we can't just box our answer, because what the heck is u? You can't you made that up temporarily, right? We've had this situation before. So you cannot leave that u in your final answer. You must put back, now that you've done the square root, you must put back whatever u is, and u is this thing in parentheses here. So you still have the plus or minus, you still have the 8, you still have the absolute value bars, but that u becomes x plus 3 in parentheses. That's why I put the parentheses there. And then you have that 3rd power out there. And this is your answer. Okay? So do you really need to write let u equal u plus 3, x plus 3? It's a good idea in the beginning just to get, kind of warmed up. But after a while, you'll realize that whatever's in the parentheses just remains what it is. See, it didn't change from here. X plus 3 didn't change from here to here. You just took the root on the outside is what you did. But you did go from a 6 to a 3, which is even to odd, which means bars. Absolute value bars are necessary. Okay. The last thing, we're done with the lesson, but the last thing I want to do is also talk about taking the roots of numbers with a calculator, because you will do that in the homework tonight. So let's say you're trying to take the 5th root of 32. How would you do that with a calculator? Well, with most modern calculators, what you're going to do is type the 5, like you want to take the 5th root of a number. You type the 5 first, okay, like that. And then you type the button, you find whatever button it is. It usually looks like this thing right here, which is a root with a little X or an N or something like that over here. So you might see a button that looks like this. You might see a button that has a Y in there. I've seen some calculators where this is an X and this is a Y. It really doesn't matter as long as you have an nth root. You have an index number here. That's the important thing. You have a root, a radical symbol with an index number, and you press that button next. Now on this calculator that I'm using, it actually doesn't have a button for that. You have to go into the math menu, and it's number 5 right there. So I'll just scroll down to 5 and hit enter. And now what you have is 5 root x root, right, like that. And then you put in your 32, and we already know the answer here is 2 from the beginning of the class. So hit enter, and you should get a 2. It's right there. So that's how you do nth roots on a calculator. Some of the older calculators, the ones that don't have a cursor at all, okay, you might have to do things backwards. So if you have an older calculator or a really basic calculator that doesn't allow you to move the cursor around, something that looks like this where, you know, it doesn't really have cursors and stuff to move around. Something like that, what you'll want to do is plug in the 32. So you'll type in the 32 first, then you'll press the button that I'm talking about, wherever it is on the calculator, and then you put in the 5, and then you hit the equals button, and then you'll get your answer, which is 2. But it's backwards. So if try, you know, with a modern calculator, you would put the 5 in first, press the nth root button, and then put in the 32, and then hit whatever, enter or equal or whatever. But with older calculators, it might be, the process might be backwards. So try this one first, okay? And if that doesn't work, if you don't get an answer that kind of makes sense, then try it the other way. You might have an older calculator. Okay, we're done. See you at the next video.
Check this.